My graph. Yes, everybody see my graph. Do you notice, are any of the points connected on there? No, so that's a discrete graph. Now, is that a function? How do I know if it's a function or not? It passes that vertical line test, right? Does it pass the vertical line test? Yes, so this is a function. Now, what you need to do, since it's discrete, is you need to do your squiggle, and you need to list your x values from least to greatest. So you're going to read it just like you would read a graph. Guys, look at me. We read a graph coming from left to right, correct? That's how you read a graph. So my first dot is right there, correct? What's my x value for my first point? -1. Then it goes to where? 1. Then. Does that make sense? Okay. Next one's my mapping diagram. Is it a function? What? No double arrows, right? What is my domain of my mapping diagram? -3, then 1, then fabulous. Now, the last one, it says equation, right? This is my equation. If you were to put that into Desmos, would you just have points or would it just go straight line all the way through? Straight line, which is continuous, which is not what we're talking about, right? So here's what you have to be careful. If this is my equation, what else does it tell me in this box? It tells us what the domain is, right? So that means if it tells you what the domain is, those are the only points you will graph. Well, if I need the domain of this equation, does the problem already give it to me? Yeah, what is it? 0, 1, 2, 3, and 4. Did you have to do any work for that? Absolutely not. So my equation, my domain, is 0, 1, 2, 3, and 4. Okay? There's your domain. Range. Domain is X, that means range is Y. In my opinion, it's not as big of a deal. Domain has to be in numerical order. The range necessarily doesn't have to, but it seems to me like every air test wants it to be. So we have to put these in numerical order as well. So we look at our ordered pairs first. What is my first Y value? 8, then 2, then -4, then -7. Now, this is discrete. So when it was domain, I did squiggles. Same thing here. I'm going to squiggle, and I want to go from least to greatest. What is my smallest value in my range? -7, -4, 2, and 8. Okay? Table. My domain, I'm sorry, my range is 3.5, then 7, then 10.5, then 14. Yeah? Rack. What's my smallest Y value? 1. Then mapping diagram. What's my smallest Y value? -13. Then -8. Then -0.5. Then 9.5, right? I'm not going to write this down. You heard me say it. You guys can do that. Equation's the new one. Does it give me the range? It absolutely does not. So how am I going to find my y values? What? I want you guys to keep your computer shut, though. Keep your computer shut. So when you come in here, what you're going to do is what I would suggest you do, actually. Y equals 30x plus 50, right? Now, what was my first domain value of my equation? 0. So what I'm going to do is I'm going to type x equals 0. And guess what I'm going to look for? Where they intersect. What's my first range value? Should you write it down? It's not 0. What is it? The 50. Be careful. You're doing your y's. Then my next domain value was what? 1. So I'm going to type in x equals 1. What's my range value? 80. Then I'm going to type in x equals 2. My range value is 110. Then I type in x equals, what's my next domain? 3. My range is 140. Do I have another value in my domain? X equals 4 is 170. Do I have any more values in my domain? So what I would suggest you do from here is make sure your number of numbers you have in here, how many domain numbers do I have? I have 5, yes? You better have 5 range numbers as well. That's not always true, but for discrete it happens more than not. Yes. Yeah, because that's your slope. Well, I'm hoping that everybody picks up on that. That's your slope. All right, now, are we good on discrete? Discrete is easy. Continuous is not as easy. So, here's your continuous. Now, did you guys notice the 2 ways that I have these written out? Discretes and dots, right? Discretes and dots. Continuous is an éponge that doesn't stop, right? Okay. When we talk about a continuous graph, you're going to hear me say these following things. Listening? I'm going to ask you, when you come from the left, you hit a point or an arrow. It's the first thing I'm going to ask you. Then I'm going to say, when you come from the right, you hit a point or an arrow. Then I'm going to say, when you come up from the bottom, you hit a point or an arrow. Then I'm going to say, when you come down from the top, you hit a point or an arrow. If you put those 4 sayings into your head, you will be fine. If you come to my pre-calc class, they literally hear me say this all the time. And if you listen to them, you'll hear them repeat exactly what I said. And it makes a lot of sense, but you have to listen. Okay? So when we are talking about a continuous graph, we will use 2 symbols. We will use either an open bracket or a closed bracket. Open bracket or closed bracket. And I'll explain what those mean in just a second. Open or closed bracket. Or we will be using parentheses. So notice, discrete, we use a squiggle, right? With continuous, you either use an open bracket, closed bracket, or parentheses. Now, we're going to talk. You're going to tell me if it's continuous or discrete. The amount of gas remaining in the fuel tank after driving X number of miles. Discrete or continuous? That's definitely continuous because your gas tank doesn't just drop at 1 or 2, right? That's definitely continuous. The number of fish in a lake at a given depth. That's definitely discrete. Are we okay on the difference between those 2? Yes? Here we go. Domain and range. Now, see how they have inequality symbols on these notes? I haven't changed it. I should have changed it a long time ago. But we'll talk about it. Domain, it says look at the blank axis. What variable do we use for domain on the other side of our notes? X. So domain, we're going to look at our x-axis. And range, we're going to look at our y-axis. Now, if you have an open circle, do you see the difference between these two? If you have, this is what we call an open circle. That is going to be a set of parentheses. And we're also going to include something else besides just an open circle. If you also have arrows, we'll go and talk about that in a second. Don't worry about that. If you have a closed circle, we are going to use brackets. If you have a open circle, it's going to take parentheses. Closed circle is going to take brackets. Now, everybody put your pencils down right now. Actually, that's a lie. Do you see where it has you make an example up here? Create your own. I want you to know how to kind of cross that off. You need to write this down, and you need to put a big box around it because this is really important. So if you have doodled in there, you need to erase that doodle right now because you got this whole spot. If you hit an arrow coming from the left, that's a negative infinity. Just write it down. If you hit an arrow coming from the left, that's negative infinity. If you hit an arrow from the right, that's positive infinity. Arrow bottom, you'll see what I mean when I do it, I promise. That's negative infinity. I can't fit the last one. Arrow bottom is negative infinity. I can't fit the last one. Arrow top is positive infinity. You need to have all four of those written down. Left negative, right positive. Bottom negative, right, top positive. Yes, I'm definitely talking about the main arrangement. Oh, yeah. Okay, put your pencils down. Because the more you use this with your eyes, the easier it gets. Now, put your pencils down. Look at graph number 4. You ready? The first question I'm going to ask you is this. When I come from the left, which direction is the left? This way, right? Boom. If you don't know your left and right, this is going to be an issue. When I come from the left, do I hit a point or do I hit an arrow? Look at your graph. Don't look at me. I don't have it on my forehead. Point or arrow? Point. If you hit a point, you need to either find the x or the y value. We're going to talk about domain first. Domain is at my x or my y value. That's my x. What is my x value at that point? -5. Does everybody see how it stopped? You should be writing anything down. Does everybody see why it is -5? Yes, no, maybe. Okay. The next thing I'm going to ask you, is that circle open or closed? Closed. Now look above in your notes. If it was a closed circle, what did I tell you we were going to use? A bracket. So what you'll do for domain is you will put a bracket. And what did I say my number was? -5. And then you're going to put a comma and then you're going to put your pencil right back down. Okay? Now, when you come from the right, so I'm going to go this direction, correct? When I come from the right, Do I hit an arrow or a parenthesis? I'm sorry, an arrow or a point? You hit an arrow. Does everybody agree? Look up at your notes. When you hit an arrow from the right, what did I tell you to write down? Positive infinity. Now, when I did positive infinity, did you guys write a plus sign in infinity? Don't. If you have a plus in infinity, guys, if you have a plus sign, you really shouldn't write that. Assume that it's positive. So what you'll do is you'll write infinity. Now I want to talk about infinity. What does infinity mean? It goes on forever. You can always add one more to it, right? So whenever you write an infinity symbol, be it either positive or negative, it has to have a parenthesis around it. Okay, so main check. Range. Here we go. When I come up from the bottom, point or arrow? Arrow. Now look above. When I came up from the bottom, if I hit an arrow, what did I tell you to write down? What? Negative infinity. So I'm going to start my range. Negative infinity. Now, whenever you write an infinity symbol, you always use a what? Parenthesis. Everybody follow me there? Yeah? Okay. When I come down from the top, you hit a point or you hit an arrow. When I come down from the top, I hit a what? Point. What's the y value at that point? 3. Why don't you get a pencil? Is it open or closed? Closed, so I'm going to put a parenthesis or bracket. You just found your first remaining. Number 5. Dot. Number 5. Okay. Where do I come first? Left. Point or arrow? When I come from the left, listen. When I come from left, point or arrow? If you don't see an arrow, it's a what? It's a point. Do you see an arrow on either ends of those graphs? No, that's a point. What is my x value at that point? 0. Is that point open or closed? It is closed. It's going to clearly be open. Does everybody see what I mean by that? So if it's closed at 0, do I do a parenthesis or a bracket? I need to do a bracket around 0, comma. Come from the right. Point or arrow? Point. Open or close? At where? At 3. Does everybody see how we're getting 3? 3 with a bracket. Why? Because it is close. Okay. Now, ready? I'm now going to come up from the left. Come up from the bottom. When I come up from the bottom, point or arrow? Point. You actually hit 2, but they're hitting at the same spot. So does it matter? No. You got to look for whichever one you see first. I hit a point. What is my y value at that point? 0. Open or close? Close. So I'm going to put a bracket around it. Come down from the top. Point or arrow? Come down from the top. I stop right here, right? Everybody agree? Point or arrow? Point. What's my y value at that point? 60. Open or close? Close, so I'm going to put a bracket. I want you guys to try number 6 right now, please. Quietly. Here we go. Domain. We get it? Yeah? Range. Did we get it? Yeah? Try 7. Ready? Yeah? All right. Could be a negative. When you come from the right, it's always a positive infinity. Right and top are positive, left and bottom. So whichever one you do first, it's going to be negative. Whichever one you do second, it's going to be positive. And there's a reason I tell you that. That's the reason. I'm serious. Kimber can attest. She heard me do this in pre-calc. And that was a long time ago. Okay, now. I have that equation, right? Everybody open Desmos on your computer, please. Everybody open Desmos on your computer, please. And I want you to type that equation into Desmos that we have on your paper or on the front board, doesn't matter. Type it in. Y equals negative 3x plus 4. Have a nice line, yes? Everybody agree we have a nice line? Now, when it comes to using Desmos for this, you have to be very smart. And you guys are, is it positive or negative 3x? Thank you. So you have that, right? Now, don't do this, but when I do this, does that ever stop? Okay, so when I ask you to find domain and range, and you're going to use Desmos a lot when it comes to graphs, my suggestion from this day on, if it asks you to graph anything, you graph it on paper, then you check yourself on Desmos, because Desmos is your cheat sheet. It really is. Is that graph ever going to end? No. So when I'm talking about domain and range, if it's never going to end, what's going to be on the end of this graph? If you were to graph this on a piece of paper, what would you put on the end of the line? You would put arrows, right? That's important to remember. Okay? Remember when we first graphed, I said don't make a DP line? I wanted you to go all the way through, and I also wanted you to do what? Put arrows on everything. Do you think there's a reason I have to do that? God, I'm good at my job, right? Okay? So, this is going to have arrows. So let's talk. My domain. What's my domain of this function? If I come from the left, am I going to hit a point or an arrow? Look at your graph. You're going to hit an arrow, so you're going to write what? Left arrow means? Nope. Negative infinity with a parenthesis. Come from the right. Pointer arrow. What? Oh, tell me. Arrow means positive infinity with a parenthesis. Yes? Bottom. I'm up from the bottom. Pointer arrow. Arrow, which means negative. Come down from the top on Desmos. Pointer arrow. Arrow, so it's going to mean positive infinity.